Hello everyone. Today we are going to discuss about the maximum power transfer theorem theoretical calculations. Okay. Now, before going to the theoretical calculations, let's see what is the statement of the maximum power transfer theorem. It states that in any linear bilateral complex network consists of energy sources and resistors, then the maximum power can be transferred from source to the load when load resistance is equal to the source resistance. Okay, so from the statement we can say that the load resistance is when the load resistance is equal to the source resistance, the maximum power will transfer from source to the load. Okay, now we will check by doing the theoretical calculations whether the maximum power will transfer or not when these both are equal. Okay, if we take the circuit here, the circuit is look like this. Okay, so we are taking the one circuit which is having one voltage source. Okay, so it is a and there are three resistors, 1 kilo ohm, 1 kilo ohm and a 1.5 kilo ohm resistors, and this is the ammeter. This ammeter is used to measure the current. This is the practical circuit diagram. Okay, this is the variable load. Here by using the decayed resistance box DRB, we will vary the load resistance here. By using this DRB, we will vary the load resistance and we will see at what value of the load resistance when the maximum power will transform. Okay, so this is the ammeter used to measure the load current. The range of this ammeter we will take 0 to 20 milliamps. Okay, this is a practical circuit diagram, and if we convert into equivalent circuit of the maximum power transfer theorem, this is the VTH. Okay, we will convert this circuit into equivalent circuit, and it is RTH that is connected in series with RTH, and it is RL is the load resistance, and IL is the current passing through the load resistance. Okay, here if we want to verify the maximum power transfer theorem, first we need to convert the total circuit into Thevenin's equivalent circuit, because the maximum power transfer theorem equivalent circuit is a combination of VTH and the RTH. That's why we need to find out the VTH first, after that RTH. So after finding VTH and RTH, let's find the after that we will find the IL load current, and after that P. Okay, let's see the procedure of each and every parameter. First we need to find the VTH here. To find the VTH, this is a given circuit, so we will convert the practical circuit into theoretical circuit. That we will replace all the meters. We will remove all the meters here. In the theoretical calculation, we will not indicate all the meters. So it is a simple battery. We are taking the 10 volt supply here, and this is the variable load resistance. To find out VTH, the procedure is remove the load resistance and find the voltage across the open circuit terminal. So here I am removing the load resistance here. Assume that it is a terminal A and it is a terminal B. Here the voltage across this open circuit terminal is nothing but VTH. We already seen this procedure in the Thevenin's theorem. Okay, now let's find out the VTH. Okay, here there are here loop 1 is there. In loop 2, it is an open circuit. Okay, in the loop 1 is a closed circuit, but in loop 2, if you see, there is an open circuit here. Okay, the current passing through the open circuit terminal is 0. Okay, so the current passing through the 1.5 kilo ohm is 0. Okay, so from this we can say that the voltage drop across this 1.5 kilo ohm is 0, as this resistor is invalid, as the current passing through this loop is 0. So whatever the voltage appear across this resistor, that is nothing but the open circuit terminal voltage. Okay, now let's find out the VTH here. To find out the voltage across the 1 kilo ohm resistor, we need to know the current. So that's why I am finding the current here. I is equal to V by R formula. To find out the current, the formula is I is equal to V by R. V value we know, that is 10. These two resistors are connected in series. 1 plus 1. We are finding the total current here. Okay. 10 divided by 2, it is 5 milliamps, because as the resistors values is in kilo ohms, we will get the current is in milliamps. And now let's find out the voltage across the 1 kilo ohm resistor. If we find the voltage across the 1 kilo ohm resistor, the formula is I into R. As current is same in the series circuit, okay, the current passing through the 1 kilo ohm and the current passing through the 1 kilo ohm is same, that is 5 milliamps. So let's find out the voltage across the 1 kilo ohm is 5 into 1. So we will get 5 volts. From this we can say that VTH, Thevenin's voltage, is equal to voltage across 1 kilo ohm is equal to 5 volts. So VTH we got 5 volts. Now let's find out RTH. Like this we will find out the VTH. Now let's find out RTH. So this is a given circuit. Okay, for the given circuit, the equivalent circuit to find out the RTH will be remove the load resistance and short circuit the voltage source. Short circuit the voltage source and we are removing the load resistance. Okay, this is a circuit to find out the RTH. If you see the circuit here, we will find out the RTH across these terminals. These two resistors are connected in parallel. Okay, when the two resistors are connected in parallel, the formula is R1 into R2 by R1 plus R2. Here 1 into 1 by 1 plus 1. We will get 1 by 2, that is 0.5 kilo ohms. If you see the now two resistors, we will remove the two resistors and we will replace with one resistor. By using the parallel operation, we are converting two resistors into one single resistor. So if we draw the diagram, this is RTH. It is 1.5 kilo ohm and it is 0.5 kilo ohm. So if you see the circuit here, these two resistors are connected in series. So from this we can write that RTH is equal to 0.5 plus 1.5, that is equal to 2 kilo ohm. Okay, so the RTH value for the given circuit is 2 kilo ohm. Now we got the VTH value and the RTH value. Now we will replace the VTH value, RTH values in the equivalent circuit. So here we will place the VTH value. The VTH value we got is 5 volts and RTH value we got 2.2 kilo ohm. 2.2. Let's remove this. Here RTH value is 2.2 kilo ohms. Okay, here we will find out the IL value here. It is IL, load current. Now this is the circuit of the maximum power transfer theorem equivalent circuit. For the given circuit, we got VTH value and the RTH value, and so we need to vary the load resistance value. Okay, for the different load resistance value, we will find out the load current as well as the power. Now let's see one by one how to find out the IL and P. For the first, I am taking the 0 kilo ohm. For the 0 kilo ohm, the formula to find out IL is, how we will find out IL? IL is equal to, as the both are connected in series, I is equal to V by R. V is VTH divided by RTH plus RL. Okay, so for the first step, we are assuming that RL is equal to 0 kilo ohms. Let's substitute here. VTH value is 5 volts and divided by RTH is 2.2. We got 2.2 kilo ohm plus it is 0. Okay, 5 divided by 2.2. Okay, if we calculate that, we will get 5 divided by 2 kilo ohm. This is not 2.2. So sorry here. It is 2 kilo. Okay. Here also it is 2 kilo. 5 divided by 2. If we calculate this, we will get 2.5 milliamps. So IL is equal to 2.5 milliamps. To find out the power, the formula is P is equal to IL square into RL. Okay, we can also use the one more formula, that is VTH whole square by 4 into RTH, but I am using this formula to find out the power. IL square into RL. The IL value we got 2.5 whole square into RL value is 0. So power we will get 0 milliwatts. 0 milliwatts for the 0 kilo ohm resistor. Now, if we calculate for the RL is equal to 200 ohms, that is 0.2 kilo ohms. If you take the 0.2 kilo ohms, so we will get, we will substitute that value here. IL, to find out IL is equal to 5 divided by 2 plus 0.2. If we calculate this, we will get 2.27 milliamps. 2.27 milliamps. Now, if we calculate the power here, P we will get 2.27 whole square into the RL value is 0.2. If we calculate this, we will get power is equal to 1.03 milliwatts. Okay, this is the value we will get when we take the load resistance is 0.2 kilo ohm. Okay, now similarly, if we substitute the different types of the different RL values, so we will see what are the values we will get when RL is equal to 0.4 kilo ohm. Take the difference of 200 200 ohms. That is 200 ohms is nothing but 0.2 kilo ohm difference. 200 ohms are 0.2 kilo ohms. Both are same. Okay, 200 ohms, that is in the ohms. If we convert into kilo ohms, we will get 0.2 kilo ohms. For the every 0.2 kilo ohms, we will calculate the load current as well as the power. For the 0.2 and 0.4 kilo ohms, we will get IL is equal to 2.08 milliamps. And for this, if we calculate the power, the formulas we use same here. 5 divided by 2 plus 0.4. If we calculate that, we will get 2.08 milliamps, and the power is 1.73 milliwatts. Okay, now this is the second value. This is the third value. This is the first, this is the second, and it is the third. If you take the fourth value, I am taking RL is equal to 0.6 kilo ohm. For this 0.6 kilo ohm, we will get IL is equal to 1.92 milliamps. 1.92 milliamps. Okay. Now, for this, if we calculate the power, we will get 2.21 milliwatts. We will get. Okay, this is about the load resistance of 0.6 kilo ohm. So why we are taking different resistors? Because we don't know where we will get the maximum power. Okay, we'll check the different load resistance values, and finally we will observe where we are getting the maximum power. Okay. Fifth, for the fifth value, I am taking RL is equal to 0.8 kilo ohms. If we take the 0.8 kilo ohms, the IL value we will get IL is equal to 1.78 milliamps, and the power we will get 2.53 milliwatt. Next, for the sixth value, we will take RL is equal to 1 kilo ohm, and if we calculate for this, we will get IL is equal to 1.66 milliamps, and the power we will get 2.75 milliwatts. Okay, now for the seventh one, I am taking RL is equal to 1.2 kilo ohm. So if we take the 1.2 kilo ohm, we will get IL is equal to 1.56 milliamps, and the power P is equal to, we will get 2.92 milliwatts. Okay, now take the one more value. RL is equal to 1.4 kilo ohms. If we take the RL is equal to 1.5 kilo ohms, we will get IL is equal to 1.47 milliamps, and the power P is equal to 3.02 milliwatts. Okay, now I am taking one more value. RL is equal to 0, sorry, it is 1 point. RL is equal to, take 1.6 kilo ohm. If you take 1.6 kilo ohm, we will get IL is equal to 1.38 milliamps, and the power P is equal to, we will get 3.04 milliwatts. Now I am taking RL is equal to 1.8 kilo ohms. If we calculate the RL is equal, for the RL is equal to 1.8, we will get IL is equal to 1.31 milliamps. 1.31 milliamps. The power P we will get 3.08 milliwatts. Okay, now let's take the one more value, that is RL is equal to 2 kilo ohm. This value is very, very important because RTH value we got 2 kilo ohm. This RL is also 2 kilo ohm. Okay, now at this value we will get the maximum power or not out of all the powers. IL is equal to 1.25 milliamps, and the power P is equal to 3.12 milliwatts. Okay, next, for the after 2 kilo ohm also we will take the some more resistor values, and we will check 2.2 kilo ohm. RL is equal to 2.2 kilo ohm, and the IL is equal to, we will get 1.90 milliamps, and the power P we will get 3.11 milliwatts. Okay, like this we will get the power values, and after that we will take after 2.2 we will get 2.4 and 2.6, 2.8 up to after 2 kilo ohm we will take 4 to 5 values, and we will find the IL value and P value. And if we summarize all the values, we will get, if you summarize all the values, see here, this is a tabular column. Up to now, we got VTH is equal to 5 volts we got, and RTH is 2 kilo ohm, and we are varying the load resistance. These two are the fixed values, and the RL is a RL is a variable resistance. If you see the resistors here, 0 kilo ohm, for the 0 kilo ohm, we got 2.5 milliamps and the 0 milliwatts. So we have calculated up to 2.2 kilo ohms. If we calculate for the 2.4 kilo ohms, the IL value we will get 1.13 milliamps, and the power is 3.06 milliwatts. For the 2.6 we will get 1.08 and 3.03. And for the 2.8 kilo ohm, we will get L is equal to G 1.04 milliamps and the power is 3.02 milliwatts. So these are the values we will get. So if we observe all the values, at exactly this value, exactly this value. Okay, so what is the maximum power transfer theorem condition? When load resistance is equal to source resistance. Here RTH value is nothing but the source resistance. When these both are equal, the maximum power will transfer from source to load. If you observe here the load resistance is 2 kilo ohm and the source resistance is also 2 kilo ohm. When these both are equal, if you see the power we are getting 3.12 milliwatts. Okay, out of all the powers, this is only the P max. Okay, hence we can say that the maximum power transfer theorem is verified. Okay, this is only we have to verify. When these both are equal, the maximum power will transfer or not, that we have to verify in the maximum power transfer theorem. So that is we verified here. When these both are equal, we are getting the maximum power. If you see all the powers, 3.12 milliwatt power is a maximum. If you again after 2 kilo ohm, if you increase the resistance value, there is a change, there is a decreasing the power. If you see, if you take 2.2 kilo ohm, the power is reducing here. 2.2, 2.4, 2.6, the power is reducing. Okay, so like this, if you observe the graph here, if you see the graph, so this is the load resistance RL. Okay, and it is the power P. So the power will increase up to certain point. After that, it will decrease. Okay, what is this value here? This value here we will get the maximum power. P max we will get. Okay, at this point we will get RL is equal to RTH. Okay, what is this RL is equal? What is the RL value? 2 kilo ohm. And the RTH value is also 2 kilo ohm. Okay, so when these both are equal, we will get the maximum power. So this is about the maximum power transfer theorem. Like this, we will verify the maximum power transfer theorem that we have seen it exactly when these both are equal, we are getting the maximum power. Okay. This is about the today's class. In the next class, we will discuss about the more videos. Thank you, everyone.